Hi, Mick McQuaid here, welcoming you to the very last of our lectures in this series. And this one is a short introduction to graph databases. So one of the very first kinds of databases in history was the network database back in the 1960s. And it relaxed an assumption of the very first computer databases, which were strictly hierarchical. And instead of every node having one parent, which would be the case in a hierarchical database, the network database could have multiple parent-child relationships. And it fell out of favor when relational databases were introduced in the early 1970s. And the network database was considered difficult to manage in comparison to the relational model. It required programming. But it served an important purpose, and it has been reborn in a sense in contemporary graph databases. So graph theory is a branch of mathematics that works with sets of objects that are called nodes, which are also known as vertices or locations or points, and edges, which are also known as arcs or links or relations. And graph theory enjoyed a surge in popularity when social networks on the web became popular, and it was found that social networks obeyed certain laws of graph theory. But representing social networks was problematic with existing databases. This is back in the 1990s and early 2000s. And so graph databases came into existence in the early 2000s and became fairly popular for representing relationships between things. And what are popular uses of graph databases? Well, the main one is social networks. There's no question that this is the dominant thing. Facebook and Instagram and TikTok and so on all use graph databases to keep track of friends and followers. It's also used in fraud detection, which identifies complex hidden patterns in financial transactions. And it's also used in recommendation engines for real-time product or content recommendations based on user behavior. And also in knowledge graphs, powering AI systems and search engines using, for example, graph RAG. RAG is retrieval augmented generation or something like that. Oh yeah, and it's also used in network and IT operations, so mapping dependencies of infrastructure, so mapping an actual physical network. The best example of a graph database is Neo4j, the most popular graph database product, and it represents three basic concepts: nodes, which are things or people; edges, which are relationships between them; and properties, which are key value pairs that are attached to either nodes or edges. And it uses a language similar to SQL called Cypher to manage databases. So it models relationships and properties, is the only difference between it and SQL. And it uses a match keyword to match patterns in the graph. And it contains a where clause to define conditions, and uses a return clause to organize the output of a query. So here's an example where the keywords begin each line and all the other words are user defined. But the punctuation is not. The punctuation is vital to specifying the patterns. So in this one, we're going to match an object called Nicole, which is of the class actor, and which has the property name Nicole Kidman. And this has a relationship. These are relationship symbols. And the relationship has the property that the person on the left-hand side acted in the movie that's on the right-hand side. And so this is an object called movie of the class movie. And we want only the results where the movie year, the particular movie year, is less than some year parameter that we've entered in. So say we want only Nicole Kidman's movies from before the year 2000, for instance. And we're going to return all those movies. A list, basically a list of all those movies. That's all we're going to get. And we can also return much more. So I'm going to show you an example. This isn't the Nicole Kidman example. This is an example from a class that I taught where I used productions of Shakespearean plays to form a network. And so these are all nodes that are produced by a pretty large query, too large really to fit on one slide. And some of these are special nodes. The play Julius Caesar, the play The Tempest. Here's the another Tempest node. Now, why are there two Tempest nodes? Performance of Tempest, produced Tempest. Oh, these are productions of The Tempest. So this is the actual play, The Tempest. This is the actual play, Julius Caesar. These are productions. The yellow things are productions of them. And there are all these various other nodes that are connected, which are, theaters, countries, cities. And you can actually modify this in the original. This is just a screenshot. In the original graph, you can zoom in on this and you can modify it, how it's depicted so that it's easier to read and so on. So I taught a class in contemporary databases a decade ago, and I wrote a 100-page study guide for it, which I've put on Canvas, and it's mostly focused on MongoDB and Neo4j, and that book is in Canvas files, contemporarydatabases.pdf. So if you want to know more about MongoDB or Neo4j, that's a really good place to start. Another good place to start for Neo4j is this book called Graph Databases by Ian Robertson et al., which I used in that class. And I used the 2015 edition. I don't know if there's a newer edition of this. I haven't checked into it since I taught that class 10 years ago. But I recommend it if you want to learn more about Neo4j. I haven't really used it since then, but I know it still exists. It's still popular. And it has advanced to the extent that all other apps in 2026 have advanced to include a lot of AI that may or may not be useful. Okay, so that's all I have to say about that. And that wraps it up for this course. I hope that you've enjoyed it, and I hope that you'll continue on your database journey. And I thank you for watching all 11 weeks worth of these videos.